Welcome to the Vision Cortical Area Types tutorial. The Vision Cortical Areas represent all the input and output cortical areas that can help with receiving, improving, and controlling robots' vision. Some Vision Cortical Areas in FEAGI include eccentricity, modulation, horizontal flip, vertical flip, lighting enhancement, lighting threshold, and blink. The central vision is in the middle region. The peripheral visions surround the center vision. Depending on where the central focus is, the peripheral regions could be in different sizes, like how in this example, the right peripheral visions are longer than the left. Eccentricity shifts the positioning of the central vision to move the focus. To complete the view, use modulation to expand and contract the size of the central vision. If you want to invert your vision across the y-axis, you can activate the horizontal flip output cortical area. On the other hand, if you want to invert your vision across the x-axis, you can activate the vertical flip output cortical area. The enhancement output cortical area's dimensions are set to 3 by 1 by 10 by default. For finer tuning, you can extend the z-axis. In this example, the 21 neuron block length automatically adjusts to -10 to +10. The data you activate is based on the size of the cortical area. Column 1 is responsible for controlling brightness, so -100% would increase the light intensity, while 100% decreases it. Column 2 controls the contrast, which similarly decreases the negative values and increases with positive ones. Column 3 controls the shadows, so -100% would have minimal shadows, while 100% would have maximum shadowing. Threshold controls the intensity of the image or video being projected, so this output cortical area is used to filter out excessive motion that often leads to unwanted activation. A high threshold means that the cortical area will only detect massive movement, while otherwise it will remain stagnant. A low threshold means that the cortical area will be extremely sensitive to any change, often activating maximum movement. The blink output cortical area, when activated, displays the opposite of the vision it observes when it blinks, temporarily blocking visual stimuli.